right, so today we are going to start talking about power. So last week we spent a lot of time talking about work and how to calculate work and the concept of work. We applied work with energy and the work energy theorem. And today we're going to continue on with that as we talk about power and what power is. So let's start with this question. Which requires more work? Lifting a 1 kilogram mass 2 meters in 1 second, or lifting a 1 kilogram mass 2 meters in 1 minute? So what's the difference in these two scenarios? What do you notice? Well, hopefully you noticed that the difference is the time. So we're lifting a 1 kilogram mass 2 meters in both situations, but the difference is we're versus 1 second versus 1 minute. So the amount of time is the difference in this scenario, all right? We're going to find out that time is going to be an impact on power and how much power we are going to have. So why is it harder to lift an object quickly? Well, that's because this is what power is. Power is the rate at which work is done, or the rate at which energy is dissipated. Dissipated means used or consumed. That's a big word. So if something is dissipated, that means it's used or consumed. So the more work in a shorter amount of time means you're going to have more power. So power is a scalar quantity. It's going to be a rate, okay? It's going to be a rate, which means it has to do with time. That's why our equation is going to be that power equals work divided by time, all right? P is going to be our power, W is work, and T is time. I'm going to go ahead and draw that triangle for you so that you can use that on your calculations if you need to. All right, so let's go ahead and draw this triangle here. We'll have our power at the top, work, and time in the bottom. Remember, to use this equation, you simply cover up what you're looking for. It tells you what to do. So in this instance, this would be work times power. Work times time is going to give you power. Now, our units for power is going to be the watts. The watt is simply the joules per second. So it is a rate unit. The joules per second is going to be watt. So you've probably heard the term watt when you are talking about light bulbs, right? Well, the wattage of a light bulb simply tells us how much power it's going to be using over a certain amount of time. Now, there's some other equations that we need to make sure that we know, because power, we can sub in some things and solve for other variables using this power equation. So we were going to recall from our previous notes that work equals force times displacement, okay? And it follows, so if we can also plug this in, so if power equals work over time, this is going to be the same thing as saying power equals our force times displacement over time, okay? So this force times displacement, remember, that is what work is. So our force times displacement is work. So by simply plugging in force times displacement for work, we are able to have more variables to solve for. Also, we should recognize that distance over time is our equation for velocity. So consequently, power is also going to be equal to the force times the velocity of an object. So these are going to be our three equations that we're going to be able to need to know in order to solve some of these problems. All right, let's work a few of these problems together, and then I'm going to have you work the rest on your own. Number 1, 2 people of the same mass climb the same flight of stairs. The first person takes 35 seconds to climb the stairs, while the second person takes 25 seconds. Which person does more work? Well, we just said that power is equal to work over time, right? Work, we know that work, this is asking for work, so work is equal to our force times our displacement. If they are the same mass, that means they have the same force, and that means they have the same displacement because they're going up the same flight of stairs. So they're both going to be doing the same amount of work because they both have the same mass and they both have the same displacement. They're both going up the same flight of stairs. So they're going to have the same amount of work. But when we want to know which person has most power, that's when we're going to use our power equals our work over time equation. So if they're both having the same amount of work, the only thing that's going to change is the time. So if we decrease our time, that means that our power is going to increase because these are inversely related. So if we decrease our time, that means our power is going to increase. So which person has the least amount of time? The second person, right? So our second person is going to have the most power because they have the shortest time. So we're going to learn, or hopefully you have figured out by now, that the quicker you can do something, the more power you're going to have. That's going to be an important thing to consider for our lab we're going to do on Friday. If an old forklift is replaced by a new forklift that has twice the power, how much more can it lift in the same amount of time? So an old forklift is replaced by a new forklift. How much more can it lift in the same amount of time? All right, has twice the power. So power equals our work over our time. And for this one, I think we're going to need to plug in our force times our displacement. All right, so power is going to equal force times displacement over time. Okay, so we're not changing time, so we're going to ignore that. We know that our forklift has twice the power. So how much more is it going to be able to lift? Well, if we add a 2 here, we're going to ignore that because that's not going to change. We're going to have to add a 2 here in order to keep it balanced. So it can lift twice the amount in the same amount of time. If it lifts the same load as the lift, as it lifts the same load as the old lift, how much time will it need? So if we have twice the amount of power is equal to our work over time, if our 2 is up here, we are going to have to put a 1/2 here in order for it to be the same, right? Because our time is on the denominator. So that means it's going to need half the time in order to lift it, right? Number 3, a certain car can go from 0 to 100 kilometers an hour in 10 seconds. If the engine delivered twice the power to the wheels, how many seconds would it take? All right, so we're looking at our power equals our work over time. If we have 2 times the power, we're going to have half the amount of time, right? That's what we just said in the previous. So what is 10 divided by 2? That's going to be 5 seconds. All right, does that make sense? So number 3, we just applied what we did on 2B. Okay, so these power calculations should be pretty easy for you to do. Number 1, you do 10 joules of work in 2 seconds. How much power do you use? All right, well, we have work equals 10 joules. Our time equals 2 seconds. We're going to use our equation, power equals work divided by time. So when we do that, that's going to be our power is equal to 10 divided by 2, which equals 5 watts. Okay, make sure you label your units. You got to make sure on these on what variables you're given. So number 2, how much more power is needed to move a 10 Newton object 2 meters in 5 seconds. So first you're going to have to know that you're going to have to figure out the work, right? Work is equal to, we don't have the work, so work is equal to the force times displacement. You're given a force and you are given the displacement. So our work will be 10 times 2, which is 20 joules. Now that we have our work, we can plug it into our equation. Our power is work divided by time. That's going to be 20 divided by 5, which is going to be 4 watts. Okay? All right, you're going to work the rest of these by yourself. I will be checking them when I am back at school. So make sure you get these done. I want you to upload a picture that you've completed these to your Google Classroom assignment. Make sure you watch this video to the end and answer the question.